Can everyone hear me, first of all? Good, okay. So we're going to be talking about state management. And we've already talked about state in React. We talked about use state and how we can pass around those setters to update state in our application. But we can do something different. So basically, use state gives us two outputs, some state, and then a function set state. And after you call set state, components that use the state re-render. This should all be reviewed, but if it's not familiar, feel free to ask on the questions doc. And that applies for the whole lecture. All right, so how do we get other components to use and update state? We have to pass them around. And we have to pass them around kind of far, because it turns out that if we have something deep in our tree that needs that state, we have to pass it all the way down the tree, which is a lot of props that don't actually relate to the component that's using them. This can be kind of confusing when you want to add a prop to some deeply nested component. And it's pretty sad. But there is a better way. So here's a concrete example of what kind of that state passing looks like. So first off, we have some code with some parent component, and we also have some child component. We export our parent, and our child uses the state from the parent, but the parent doesn't really actually use the state itself. It doesn't use the name directly. So this seems like a kind of weird example because the parent really has no need to use the use state, but we can ignore that for now. In some more complicated code, it's probably there are cases where you would need the set state in the parent, but the variable in the child. So first, we're going to import our use state hook. Then we're going to set up our state and initialize it to Alice. After that, we're going to set it to Ben. And our parent component will then pass the state as a prop to the child. Our child component has user as part of its props, and then it's going to as part of its props, and then it re-renders. So more concretely, what we have here is if we had some state name in our application and we wanted to pass it down all the way down the tree to G, we'd have to pass it down from app. We could just put it in F, but if it was also necessary in say E, that would be really inconvenient because now it has to be an app, even though it's only being used in two components and a bunch of components need it that don't actually care about it. But we can actually use this thing called a context. So there's a hook called use context, and that's what we're talking about here. We can make a context C, and a context is kind of like a value. We're talking about a context as a value here. And then we could use that context in any descendant of this special component returned by use context, which is context.provider. And then to change the value, well, we can use state. We could also directly mutate it, but that wouldn't actually cause React to re-render. So we'd be kind of we don't really want that. We want React to re-render when this changes because it's important to our application and important to what the user views. So to recap, we can make context using use context, and then we can use that context value in any descendant in the tree of this component that we can access at c.provider. And we can change it using use state. But what if we want to change it in many places? Well, then we have to pass around the set state part for C as well. And to do that, we have to also pass around the use state hook as context. And this is fine, but it can be kind of annoying when you have a lot of state going around and you still want to use contexts. Also, it becomes kind of hard to reason about where your state changes. So it'd be nice if we could make sure that everything changed in only one place for debugging, because, well, or one place meaning one file, really. So if we only had one file a few lines of code, one function that ever changed C, then we could figure out what's going on pretty easily because we could just look in that file and say, oh, we have a bug. Let's walk through this code and see where it behaves differently from how we expect. And it becomes easier to know where C gets changed because we can just search for where that function is called from. This is a thing called dependency injection. If you haven't heard of it, don't worry about it. But if you have, a little Easter egg. So Mark's going to go through some examples of how contexts actually pass through the React component tree.
Okay, can you guys hear me? Actually, this is not good. Wait a bit. Okay, can you guys hear me? Okay, so first we'll start with a example. We'll walk through it together. Okay, so suppose we have this component tree where we have our app, and then we have it has two children. And on the left we declare some use context, and this context contains is like around the components A, B, C, and D. And then inside of this use context, we declare that some context where x equals 5. And so what would be the value of the variable x in A and also in D? So the value of x in A and D would be 5, because we have declared the context x equals 5 inside of all of these components, or is like around all of these components here. And so maybe one thing we might wonder is like, okay, now if we have this context here, what would be the value of like x and f, for example? And we wouldn't know, because the context that we define is only around these components, and we've set x equal to 5 here, and we don't really know about what's going on in any of these other components. And so here's an example for everyone to try. So if we have this component tree here, and we have our context here, and our context in this case is some user, which is bin, what would be the value of the variable user in B? I'll give everyone a few seconds to think about it. And so like the last example, we wouldn't know, just because the context was only defined inside of these components here. And so what would be the value of the variable user in C? And so in this case, it would be bin, and that's just because C is inside of our use context here. And so maybe one thing is like, so far we've only had, like in the previous slide, we only had one context. And this might work for some simpler applications, but maybe in some more complex application, we want to have a lot of state, and we need a lot of state in many different components. So can we have multiple contexts at one time? Or are we like bound to only have one context? And the answer is if we have something like this, is something like this possible? We have some context around this whole subtree here, but we also have the context from the last slide where it's just around this part here. And so we can't have something like this. We could just have to define it twice. So we set up one for this component tree, but we also set up one for this one. Oh, sorry. Okay, does anyone have any questions so far? Okay, I'm going to hand it off to Jay to talk about state machines.
All right, so state machines are some useful background that we actually probably want to understand the second part of this lecture, which is about reducers. And what a reducer is kind of like a state machine, but we'll get into that in a sec. So we've talked about contexts. They let us pass around a value within like some subtree of our component tree, and we can just access it like a normal value, and it will just magically have the value it was assigned before. And if we want to change it, we can use useState. That's just recapping, but now onto state machines. So state machines have some initial state. They have some transition function, which accepts a state in an action and then gives back a new state. And we can think of a few examples of things that we can model with a state machine. So we have like a washing machine. Its initial state is going to be off. And then when its transition function sees that the current state is off and it's turned on, and then it goes to rinse and close. And then over time, after enough time has passed, it's going to transition from rinse and close to done. Modeling that with a transition function is like kind of fuzzy. You can imagine that like the action contains how much time has passed, and that would also work. We could also imagine a garage door, which switches between being closed, opening, and then open, and then closing again before it becomes closed. So the big idea here is that we have like some sequence of states that we go through, and depending on the actions that we take, the state that we're in changes. Lastly, we also have an example of an oven, and this is kind of interesting because like the state contains some like temperature that the state like is different based on, but the transitions themselves are similar. So the oven goes from off to warming up when we preheat it to a certain temperature. And then it goes to on only when it actually reaches that temperature. But there's like kind of a family of states of on at like 400 degrees, 425 degrees that are all transitioned from warming up. And then it cools down and then it turns back off. We're going to go through a few diagrams of how this actually looks because I think that might help in terms of making this more understandable. So here's a washing machine. It starts out off. If we wait after turning it on, it'll rinse close. And then if we wait, it'll eventually be done. And turning it off at any step always brings it back to off. And then we have an oven and it starts out off. We preheat it to like X degrees, and then it's in the state of warming up to X degrees. So like one way to model this is that we could have a different state for 400 and like 325, but that would take up a ton of space. So I've just written it like this. But the point is that states can carry information as well. Like states aren't just what state you're in. The state can also be like, can also have extra information. And that's more like what we're talking about with React or with React reducers. So we'll get to that in a sec too. And then if we wait from warming up to X degrees, we reach the state where it's on at X degrees. And then again, if we turn it off at any point, it turns off. Not all ovens have a cooling down step, so I didn't model it here. So first off, any questions about state machines before we get on to reducers? They've probably already been covered in like some class. I've seen them like many times. So if you're familiar, that's fine. If you're not, that's okay too. Okay, cool. Questions doc is also a good place to ask about them. I am sure that our staff will be able to answer questions. All right, so we saw contexts, and now we have reducers. And reducers are like that transition function, a function from a state and an action to a new state. So we have some initial state, and then we don't mutate that state. We just return the new one. Why do we do that? Well, if we mutate the state, it's hard to see what it was before. So seeing the past state is nice for logging and debugging. I guess an example of this is with the oven example. Like we would like to know that we were previously preheating at like 400 degrees and now we're actually like stable at 400 degrees. Now we're like on at 400 degrees. Because maybe we're worried that we're preheating to the wrong temperature before we get to a certain temperature. Because then like our oven's at the wrong temperature probably, so we cook things incorrectly. So reducers are actually just state machines, and they'll name their transition function next. They usually call it dispatch instead of like next as you would in a state machine. How do we actually call this dispatch function? Well, we can import it. And the syntax for a reducer is very similar to use state. You specify the transition function, and then like some initial state, and it gives you back the state value or like the actual value, as well as this function that you usually will name dispatch. So it's kind of like use state, but with an additional parameter for the function, or for like the transition function. We'll look at an example like in depth in a few slides. So why would we ever actually prefer this? It seems like we just added a bunch of complexity to mutating our state manually. And like, we don't like complexity usually. So we can put all of our update logic in a single place, which is the big idea here. Like all of our like logic for how we update the state in a reducer is in the definition, is in where we called use reducer, like is in that function we passed in. So we then only have to worry about dispatching the right actions to our dispatch, like calling dispatch with the right actions. So let's say, for example, that we're trying to log errors on our website and have a bar show up on the bottom for when the user does something wrong. We just have to make sure to call that to call dispatch with the right like kind of error. And then in the update logic, the part that actually like represents that list of errors will handle being changed in exactly one place. It won't be like we have to add to the list in multiple places in our code. So we're not worried about making mistakes or like having to change it in multiple places if we want to change how our like errors are displayed or how our error data looks. We also get the benefit of atomic updates. And what this means is that an action happens all at once if you're not running any async code in the action. This is pretty nice because if an action happens all at once, then we know that we're not going to observe some partial state, like some half-added item to our error list. So we won't so the whole point is that we won't see some incomplete error. We'll see the full error or we won't see anything at all. And this is nice for users because seeing that incomplete state would have caused a re-render. So they would see some like partial state in the middle. You could kind of imagine that like that the partial, like in a game, for example, the partial state could be like having like losing your item. Like let's say you're using your items to make something, like using items in some inventory to make something. Well, you lose the items, but you don't have the thing you made yet. If you were able to observe that and it stayed on your screen for too long, it'd be pretty confusing. You'd be like, where'd my item go? And then when the item you're making eventually shows up, you'd understand, but it'd be kind of frustrating because there's just lag there. So why are they named reducers? There's this extra function on arrays that we didn't really talk about in our advanced React lecture called array.reduce, or in our advanced JavaScript lecture. And it's called array.reduce. It looks very similar to our reducers. So you call reduce with a function that accepts the previous state and a new item. And then you compute the next state, and then you return the next state. And what this does is it aggregates an array into a single value. The air quotes there are because it doesn't actually have to be a single value. Like it could be another array. But the point is, if you were like summing over a list, for example, the way you compute the next state could be adding the new item to the previous state. And the previous state would be like the current running sum. So you can use reduce to implement things like sums, products, and that sort of thing, which is kind of similar to what we're doing, except we're like incrementally adding the items by dispatching actions. Any questions so far? Okay. Again, questions doc is open. So we're going to go over some example reducer code. Don't worry if the code is small. We're going to talk about every part of it in some pretty like fine detail. Hopefully this is not too small, but is this viewable for everyone? It's like kind of rough at the back of the class. Okay. If it's hard to view, I recommend pulling up the slides if you can and just like zooming in. We can try to zoom in on it. I don't think we easily can though. Okay. All right. So this is what a reducer actually looks like. We call this hook use reducer, and we pass it our transition function. And our transition function in this case is going to say roughly, if the type is add, then make a new list that includes all the existing state and then adds a new entry with an ID that is the length of the old state, and the name is the name given in the action. And then if our type is remove, we're going to keep every item but the one we actually want to remove. And we do that by using the index. So when we remove an item, we're going to pass in the index as part of our like object that we pass into dispatch. And that index will be if that index matches the index of an item, then we remove it. We're also using the 2-argument form of filter here that includes the index as well as the item, but we're not using the item here because it doesn't matter. And we have the index, or like the caller of dispatch will have to have the index somehow, but we'll get into who's calling that in a moment. So we can read the state with the items variable that is also returned from use reducer, and we can change it with dispatch. But how do we actually use this code in a component? First off, actually, any questions about what this code is doing? Okay, so next slide then. All right, so this function, handle submit, is meant for when you submit a form. And the first thing we do is we prevent the page from reloading when the form is submitted. We care about this because by default, when you submit a form, a page reloads, but you can use prevent default to stop that from happening. And then we dispatch an event of type add, and its name is going to be the current value in the input box. The way we got that current value in the input box was by using the useref hook that we kind of talked about in the games lecture. But the big idea there is like the input box has a value and we just update that value and we store the current value of that, or we store the current thing in the input box in this variable input ref. And then after that, we reinitialize the current value to nothing. So just to recap, we call dispatch with add here. And what that's going to do is that's going to give us back our existing state with the addition of this new item. And it's going to be at some unique index, which is like the current length of the list. So the indices will go like 0, 1, 2. And then if the current length of our list was 2, then this new thing will be at index 2. And the name, again, is whatever was in the input box. And then lastly, whenever the form is submitted, we're going to call the handle submit function, or we're going to call handle submit. And that's just using the onSubmit prop of a form. And we're passing in input ref as a reference to input. That's one way to get the value of the input out of the input. So that way we can use the input ref in other places in the code, and we can trust that its value will be whatever is in the input box. And then the way we display our text is, or the way we display our items is with some unordered lists, so like bullet points. And we're going to have the name of the item that's in our shopping cart, as well as a button that when we click it, items are removed, and we pass in the index of the item. So we have the index because we got the index from when we were like constructing our unordered list. And then when we click it, we're going to dispatch remove. And again, what remove does is it keeps every item except one with that index. So it'll just remove that item. And lastly, the button has a little X inside of it. So it's like actually, so we know that it's a delete button, or so the user knows it's a delete button. Also, you'll note that we're using the item's ID as a key property instead of the index. This is nice for mostly the reason that you want to have unique key properties across items so that React knows when to re-render. We talked a little bit about this in the games lecture, but I just want to reinforce it. Like the point of the key property is letting React re-render more efficiently. So using unique keys will like make your web app more responsive, but it's like not critical. So React will give you warnings about it sometimes if you don't use unique keys. It'll just re-render more often, which is like bad for responsiveness, but fine functionally most of the time. So we're going to go over this. Okay. We're going to go over this example of reducers. So first off, we start by, we're just going to look at the reducer itself for now and not any of the code that uses the reducer state to like render a component, because we mostly care about thinking about what's in our list. That's like the big important part of our logic. So we have this event of type add with name cheese, and it's going to make our items list just be a list with an item with ID 0 and name cheese. If we then dispatch an event add with name bread, then our list is going to gain that item. Does that make sense to everyone so far? Okay, cool. And lastly, if we add, or if we reuse an event with type remove at index 0, then that's going to remove whatever item has is at index 0 in our list. So that's going to remove the cheese item. So then we'll just have bread with ID 1. But its index will now be, but the index of that item will now actually be 0. So if we called remove 0 again, it would delete bread now, because when we re-rendered, there was only one item in our list. So the only index that's actually valid in that list is going to be 0, which can be kind of confusing. The index and the ID aren't always the same. Like the ID is always increasing, but yeah. Or the ID should always be increasing. I think this example code does something kind of slightly incorrect. My bad. I pulled it from a site that that I'll like link in a second. But it should probably be taking the max of all the IDs and just adding one to it, or keeping some global state for the current maximum instead of taking the length of the list, because you can get ID collisions this way. Like the length of the list right now is going to be 1, so you're going to get 2 items with ID 1, but that doesn't. We're using the ID as a key, so it'll just make re-rendering performance worse. Any questions so far? Okay. I'm going to hand it off to Mark to talk about how we can share reducer values. And it turns out we're good.
Okay, so how can we share reducer values? And kind of what we talked about before was use context. And so we can actually use context to share reducer values. And the way we can do this is we can export the dispatch function from one central place, namely being some file, because we can keep all of our dispatch stuff and our like file and like all of these functions in just one folder or one file. So whenever we actually need to update anything, we can just like work solely in that file. We don't have to hop across many files to like implement the logic for updating our state. And so since all of our dispatch function is just like in one place, we can just export it from that function into the files that we need to use it. And so use context and use reducer together is used for generally simple state management. And the reason why this is nice for simple state management is because we can change state in a centralized file without having to pass it around explicitly. And we can usually do this by dispatching actions to modify the state. So kind of like how Jay walked through, we had some example, like the example, we had some like list and we were storing some items. So we would dispatch actions to modify the state. So like adding or removing things from that list. And so with using use context and use reducer, we have something that's more declarative. So we explicitly kind of like say we want to like add or remove something. And this kind of like plays into our state machines. And so because we're using something that's more declarative, it's more understandable for us. And it's easier to change how we handle updates if the logic changes. So now that we have everything in one file, if we decide to like update our state, we can just change it inside of that one place or like pass in that function into our dispatch function. And so if we ever have any issues, we know that like our dispatch function is like written in our dispatch.js file, and we're able to update it there to like maybe like do some console logging for debugging or anything like that. And so this kind of gives us a sneak peek into Redux, which is a more complex state management library. And the power of this library here is that it leverages immutability a lot more. With Redux, we also get better tooling since it's a huge library. And so kind of to dive more into it, it's like everything that we saw with use context and use reducer, except there's a lot more to it. So I kind of just mentioned that there is better dev tooling, so we can kind of see what actions are emitted from like using Redux in our browser, which by just like using inspect element and things like that. We also get time travel debugging, which allows us to replay actions that were emitted and watch the state change. So kind of like in our state machine, maybe we want to like see what was like our previous state. Then Redux gives us the ability to do that. We can also easily log actions to see what's going on in the app. So that's kind of being able to just like walk through with Redux to kind of see how our state's changing and like our state machine. However, with Redux, it's a little bit structurally different. With Redux, we get one single global data structure that reducers are looked up in. And so with like use context and use reducer, we defined some like subset of components where we actually use the context. But with Redux, it's global. So kind of like how Enrique mentioned yesterday with Svelte, we had something that's global. Redux gives us something here that's also global. But generally, we need to be careful when we're using global variables because there could be some behavior that we don't like always expect. But like even if these global variables are generally bad, a lot of the tooling and like debugging that we get with Redux makes it a little bit easier because we can tell when things change. And because Redux is global, and it's just like a lot more, it's like generally like a lot more complex. It has more complexity than use context and use reducer. And so just to walk through some examples. So first we talked about, like we mentioned that we could just use state and pass around like our state and our setter, like through props into other components. We also talked about use context and use reducer in like maybe a little bit larger applications where we need to like have those things in like a tree of components. And then we just briefly talked about Redux and like how it's more complex and it gives us something that's global. So we have some examples here. And so the question is like, should we use state management at all in any of these examples? And if we should, which one should we use? So the first example is like a counter component, kind of like in Catbook. So in Catbook, we just had like our browser and we had a little counter, and every time you clicked, it like incremented the counter. So in this example, should we use state management? And if so, what should we use? I'll give everyone like a few seconds to think about it. So here we don't actually need to use state management because it's like such a simple, like at that point, Catbook was super simple. We really just had our counter and we just needed to really keep track of that. So we don't really need state management in this case. Example 2, maybe we have some task management dashboard, kind of think like Notion, that has like a task list, a task detail view, and maybe a sidebar with some filters. So in this case, what should we use state management? And if so, what should we use? I'll give everyone a few seconds to think about it. And so in this case, we should probably use context and use reducer just because our application here has gotten a little bit more complex. We have a task list, a task detail view, and a sidebar with some filters. So it'd be pretty helpful here because we have like multiple views, multiple components that maybe we'd want to use context and use reducer. And our last example, we have a large e-commerce platform with a shopping cart, like maybe like Shopify, user authentication, various product pages, like any shopping platform today. And in this example, we would probably want to use Redux. And the reason why is because we have maybe hundreds or millions of products across many pages. We have our shopping cart, which needs to keep track of like what we've added to the shopping cart, maybe what we will eventually remove from the shopping cart. And we also have like user authentication so that it's like each shopping cart is like specific to one user. And so just to kind of wrap up this lecture, there's a lot more that we haven't said, and Redux is generally pretty complicated. However, with Redux, we have interesting performance optimizations. And so like one of those would be like it only re-renders when relevant state changes. And that's kind of like one power of Redux. However, like I said, Redux is more complicated and like it gives us that globalness, which we want to be careful when using. And with like anything, as we keep adding more overhead to our applications, it adds complexity. So with adding state management, we inherently add complexity. However, if we manage our state well, it can make code a lot more maintainable and easier to understand. So like in some cases, maybe we'd want to use a Redux versus use context to use reducer. Maybe Redux would give us something that's more maintainable and easier to understand as our applications get larger. And so kind of just like an idea is that maybe anything that we've talked about today is a good idea for a project, depending on the project or like the type of project that you're implementing. And so with that, that's the end of the lecture. Me and Jay will take any questions if anyone has any before we hand it off to Stanley. Okay, so with that, that is, we're going to hand it off to Stanley to talk about Next.js and serverless. We'll need to go and yeah. So yeah. Yeah. You're right. Are you good screens? Yeah. It's not.
Yeah.
You do it now.
Yeah.
Should get your phone now.
Hmm?
Should get your phone. Or the slides. Yeah.
Oh, I could just press space. That's fine.
Oh, if you don't do it for slides.
Yeah.
So we use slides in workshops.
Can you guys hear me in the back? Thumbs up. Okay, cool. So today we're going to be going over serverless with Next.js. Yeah. So first of all, we should talk about what serverless is. So you might hear several phrases being thrown around, like serverless computing, serverless functions, and serverless architecture. But essentially what serverless is, it's an approach that allows you as a developer to focus more on the actual programming, and you let the handling of server architecture to some sort of third-party service. The code that you write is essentially bundled into functions, and these functions are then packaged up and sent to your third-party services who trigger it for you.